Okay, so this idea where static type checking is possible, this is mainly because code is just the same as text. So as I mentioned, if you have two files over here, one for your Python program and another for your, well, this is just some random text program. These two are essentially the same thing if you think about it. They're just consecutive characters of text. So that means that external programs can read these files as if they were just standard text files. And this is mainly the reason why static type checkers can analyze Python programs without having to run them. So, in other words, if we were to think of these static type checkers as Python functions, they would look like this. So, your problem is you have some string that represents Python code, and our task is to determine whether that Python code has type errors or not. So you can think of it as kind of a meta problem. Your input is a program itself, and you want to determine whether that program you get as input has type errors or not. Okay, so here's one example. This is a program inside your program. So we already know from a while ago that this should not pass type checking. So essentially, how these tools work under the hood is essentially something like this. They take in some program text, and based on that program text, they either make it pass type checking or make it not pass type checking. At the end of the day, these are also programs, so they work kind of like this. Of course, they're a lot more complicated since they have to actually solve this problem that we're laying out right here. But yeah, at a very, very high level, this is how they work. Okay, so in one of the later lectures, the last lecture in particular, we'll be seeing more consequences of this idea. The idea that all code is data. Okay, so aside from just the standard type hints, so far we've seen for basic values for like integers, strings, and similar stuff. Python also supports more complex ones. So if you want to type a list of something, for example, a list of integers, you would type it like this. So just wrap int around list. If you want a tuple of two things, of two integers, for example, you would write it as tuple containing two integers. Okay, so of course you can also have nested sequences. So you can also have type hints like this. So it's a list of integers. Okay, so that's for variables. How about functions? So when it comes to functions, to annotate the types, you can do it like this. So for the inputs, it's actually the same way as yung variables here. Just put a colon, then its type. And then for the return type, you have a right arrow here, then yung expected return type. So this is for the input, and this is for the output. Okay, so if you type your function like this, for example, these calls are going to fail type checking. This first one because it expects the input to be a string, but it gets an integer here. And for the second one, you're essentially adding a boolean, what you expect out of this function, with a string. So you can't add a boolean with a string. So the second line also fails type checking. Okay, so this is just a very basic overview of types. There's actually what we call a holes theory. So this is actually a subfield of math. So types are very much related to other fields that you would encounter in math. So if you've heard of stuff like category theory, then types are very much related to those. Okay, one of the main consequences that we get from type theory is stuff like this. So this Curry-Howard correspondence, this is essentially saying that types are the same thing as proofs. So in order to prove that things are true, you can use types for those. So that's just a very surface level explanation of this. But yeah, the point is there. The point is it's very interesting. So if you're curious about this, you can just search up type theory, and that should lead you to stuff related to what you see on this slide over here. Okay, so for Python, note that these type annotations are actually optional. So even if I remove this, Python wouldn't complain at me. For some other languages, they do require you to actually add type hints. So for example, if you've heard of languages like Java or C++, these languages require you to always annotate your variables. So those languages where they check your types before actually, well, running the program itself, we say that those are statically typed languages. While Python, since again it doesn't care about whether you have type hints or not, we say that it's dynamically typed. It only checks that the types work out during runtime. Okay? So in the labs, you should have these tools, MyPy and PyWrite, available to you. So we do encourage you to use these tools as much as possible in order to make sure that your types do check out. Okay? So yeah, that's for types. For CS11, again, we won't strictly enforce using type hints, but we do strongly encourage it. Okay? So yeah, that will be the last topic for this lecture. In the next topic, we'll be going a bit deeper into anonymous functions and more things that you can do thanks to them. Okay? So yeah, that's going to be the end of lecture 22. Thank you for watching.